Now that we have defined the double integral, which can be interpreted as the volume underneath a surface, let's see if we can estimate the volume underneath a surface, say the square root of 16 minus x squared minus y squared, on a rectangle between -1 and 3 in x and -2 to 2 in y. And we're going to estimate the volume of this hemisphere within this rectangle by using the midpoints of 16 squares to define the heights of my rectangular prisms. So we're going to subdivide this rectangle into 16 squares. So that requires 4 squares across, and then 4 squares up and down. And then what we're going to do is in each one of these squares, we're going to take the height of our function, square root of x squared, or 16 minus x squared minus y squared, to be the midpoint of one of these squares. So in this case, we need to look at the widths of these squares. So delta x is going to be 3 minus a -1 divided by 4, or 1. And then delta y is going to be 2 minus a -2 divided by 4, because we have 4 squares going up and down. And that's also going to be 1. And then we're going to define these midpoints. So the midpoints are going to be x sub j, and they're going to start at x equals -1/2, and then we're going to add j times delta x, which is 1. So the midpoints, if I just list them for x, are going to be -1/2, 1/2, 3/2, and 5/2. And then for y sub k, if we want to define the midpoints for the y's, well, they're going to start at -3/2 in the y direction, and then we're going to add k times delta y, which is 1, and so the y's are going to be -3/2, -1/2, 3/2, 1/2, and 3/2. So if we're going to estimate that double integral of my function, the square root of 16 minus x squared minus y squared dA, then what we're going to want to do is do a double sum. Okay, j is going to go from, in this case, the way I've indexed it, it'll go from 0 to 3. And then k will go from 0 to 3. And then we want to take the square root of 16 minus xj squared minus yk squared. And then we want to do delta a. Now delta a is delta x times delta y, so that delta a is going to just be 1. And then just to get a sense of how this works, I want to start writing out the terms of the double sum. So what I'm going to do is I'm going to start by letting j be 0. Okay? So if I let j be 0, then so I'll put that kind of in quotes here so that we can see j equals 0. Then that's going to be the square root of 16 minus, okay, when j is 0, I'm going to get negative 1/2 squared minus, and then the first y is going to be negative 3/2 squared. So that corresponds to j being 0 and k being 0. And then I'm going to have plus the square root. That gets multiplied by 1, of course, which is the delta a, of 16 minus, again, negative 1/2 squared minus negative 1/2 squared. A third one, 16 minus negative 1/2 squared minus 1/2 squared. And then one more term here, so let me move this over so I can fit it. This will be the square root of 16 minus negative 1/2 squared minus 3/2 squared. So that's just when j equals 0. Then we would move down to when j equals 1 and add more terms. So those terms are going to look like plus the square root of 16 minus 1/2 squared minus negative 3/2 squared plus square root of 16 minus 1/2 squared minus negative 3/2, negative 1/2 squared plus the square root of 16 minus 1/2 squared minus 1/2 squared plus the square root of 16 minus 1/2 squared minus 3/2 squared. So that would be the j equals 1s. Okay. And then now we're going to do j equals 2. So the next j point, xj, is 16 minus 3/2 squared minus negative 3/2 squared plus the square root of 16 minus 3/2 squared minus a negative 1/2 squared plus the square root of 16 minus 3/2 squared minus 1/2 squared plus the square root of 16 minus 3/2 squared minus 3/2 squared. And then finally, okay, we're going to do the last j equals 3, so that my x's are all going to be 5/2, so 16 minus 5/2 squared. And then my k's are going to run, my y sub k's are going to run from negative 3/2 up to 3/2. So here we have 16 minus 5/2 squared minus negative 1/2 squared plus the square root of 16 minus 5/2 squared minus 1/2 squared, and then the last term is the square root of 16 minus 5/2 squared minus 3/2 squared. So running across the bottom, right, we have when k equals 0, k equals 1, k equals 2, and then k equals 3. Okay, so my sum is the sum of the volumes of 16 rectangular prisms. And the volumes of those 16 rectangular prisms whose base areas are 1 and whose heights are given by the function the square root of 16 minus x squared minus y squared, we sum those all up and we get the volume underneath, or an approximation of the volume underneath that hemisphere within that square. I'm going to give you an approximation. It's usually helpful to use some sort of calculator to do this, or some sort of software. They can be set up in all sorts of different softwares. I actually like setting this up using Desmos, but this is going to be 56.217 approximately. So that's going to be the volume underneath that hemisphere within that square.